Your next AI assistant may not wait for a giant server to answer you. It may listen, summarize, translate, and search through parts of your life without leaving your phone at all. That sounds backwards, because for the last few years, the story of AI has been huge data centers, huge chips, and huge models. The bigger the model, the smarter it seems. So why are Apple, Google, Microsoft, Qualcomm, and almost every major device company trying to move more AI back onto the devices in your pocket? The simple answer is that the cloud is powerful, but it is not always where AI is most useful. If an AI needs to answer instantly, protect personal data, work offline, or run millions of tiny tasks every day, sending everything to a remote server can become slow, expensive, and awkward. The future of consumer AI is not only one giant brain in a data center, it is becoming a split system. Some intelligence lives far away in the cloud. Some intelligence lives right beside your camera, microphone, keyboard, photos, notifications, and apps. And that split changes what AI can actually do. To understand why, imagine two different ways to ask for help. In the first version, you type a request into an AI app. Your phone sends that request across the internet to a data center. A large model runs on powerful servers. Then the answer travels back to your screen. This is Cloud AI. Cloud AI is why modern chatbots can write long essays, analyze complicated documents, generate detailed images, and reason through hard problems. The server may have far more memory, far more electricity, and far more specialized hardware than a phone ever could. In the second version, the AI model is already stored on your device. Your phone does not need to send the whole request away. It uses its own processor, often a special chip called a neural processing unit, to run the model locally. This is on-device AI, also called edge AI. The word edge just means the edge of the network, not the central server, not the faraway cloud, the device in your hand. This is not a brand new idea. Phones have used local machine learning for years. Face unlock, camera blur, voice wake words, autocorrect, and spam detection have often depended on small models running nearby. What is changing now is the type of AI moving onto the device. Generative AI is joining that older local AI toolbox. Instead of only recognizing a face or improving a photo, a local model can summarize text, rewrite a message, classify a notification, understand a screenshot, translate speech, or help an app respond more intelligently. It may not be as capable as the largest cloud model, but it can be available at the exact moment your device needs it. That is the key idea. On-device AI is not trying to beat the biggest cloud models at everything. It is trying to be close enough, fast enough, private enough, and cheap enough for everyday tasks. The first reason this matters is latency. Latency is the delay between asking for something and getting a response. With Cloud AI, even if the model is fast, your request still has to travel. Your phone sends data through Wi-Fi or cellular networks. The server waits its turn. The answer comes back. Usually, this is quick enough for a chat message, but it can feel too slow for things that should happen instantly. Think about live translation while someone is speaking. Think about a pair of smart glasses trying to describe what you are looking at. Think about a car that needs to interpret a voice command while driving through an area with weak signal. Think about a keyboard suggesting a better sentence as you type. In these cases, even a small delay can make the experience feel broken. Local AI can remove the round trip. The device does the work right there. This is why on-device AI often feels less like asking a chatbot a question and more like the device itself became smarter. The second reason is privacy. The most useful personal AI needs context. It may need to know what is on your screen, who you are messaging, what is in your calendar, which photos you took, which files you opened, or what you usually do at certain times of day. That context is extremely sensitive. A generic chatbot does not need your entire digital life to answer a trivia question. But a personal assistant that can actually help you may need access to personal details. On-device AI gives companies a way to say, in effect, the model can use some of that context without uploading all of it to a remote server. Your phone can summarize a private message thread locally. Your laptop can search your own files locally. Your keyboard can improve a sentence locally. Your camera can recognize what is in the frame locally. But there is an important misunderstanding here. On-device does not automatically mean private. It depends on the operating system, the app, the permissions, the model, the logs, and whether the device later sends results somewhere else. A local model can still be part of a system that collects data, and a cloud model can still be designed with strong privacy protections. So the real question is not just whether AI runs locally. The real question is what data is used, where it goes, who can access it, how long it is stored, and whether the user has control. That is why many companies are building hybrid systems. The device handles what it can. If a request is too hard, the system may send a smaller, carefully packaged request to a private cloud system or a larger model. Ideally, the user gets the benefit of both worlds: local processing for personal context and quick tasks, cloud processing for heavy reasoning and larger jobs. Before we go deeper, if this kind of practical AI explanation helps you understand what is actually changing underneath the hype, consider subscribing. The goal here is to make future technology feel less mysterious, one mechanism at a time. The third reason AI is moving on to devices is cost. Cloud AI is not free to run. Every answer from a large model uses expensive chips, electricity, cooling, networking, and maintenance. If millions of people ask a model to summarize every notification, rewrite every text, label every photo, and listen for every command, the bill can become enormous. On-device AI changes the economics. The phone or laptop you already bought does part of the work. A tiny local model can handle small tasks without contacting a server every time. For a company, that can reduce cloud costs. For a user, it can make AI features feel more immediate and more available. But the cost does not disappear. It moves onto your device as battery drain, heat, storage use, and hardware requirements. This is where the trade-off becomes very real. A large cloud model can be huge because it lives in a building full of servers. A phone model has to fit inside the limits of a pocket computer. It has less memory, it has less cooling, it runs on a battery. It shares resources with the screen, camera, modem, apps, and background tasks. So engineers compress models. They make smaller versions. They quantize them, which means representing the model with fewer bits so it uses less memory and compute. They specialize them for common tasks. They use hardware accelerators that are better at AI math than a general CPU. This is why you hear names like Nano, Small Language Model, Neural Engine, NPU, and AI PC. Underneath the branding is the same basic goal: make a model small and efficient enough to run near the user. But smaller models have limits. A local model may be great at rewriting a message, summarizing a short note, extracting a date from an email, or deciding whether a notification is important. It may struggle with complex reasoning, long research tasks, advanced coding, detailed image generation, or questions that require fresh information from the web. This is the mistake many people make. They hear on-device AI and assume it means the same chatbot, just offline. Usually, it does not. A better way to think about it is like the difference between a pocket calculator and a supercomputer. The calculator is weaker, but it is always with you, it responds instantly, and it is perfect for many everyday problems. The supercomputer is far more capable, but you do not use it to split a lunch bill. On-device AI is the pocket calculator version of intelligence. The cloud is the supercomputer version. The best systems will know when to use each one. This creates a new layer inside your device. You can think of it as an AI traffic controller. When you ask for something simple, the controller keeps it local. Summarize this notification. Suggest a reply. Clean up this sentence. Search my photos for a receipt. translate this phrase. Detect whether this call might be spam. When you ask for something harder, the controller may reach for the cloud. Compare 5 long documents. Generate a complex video. Do deep research. Write and test code. Answer a question that depends on current events. The user may not always see the handoff. That is part of the design challenge. If the system works well, it should feel like one assistant, even though different models are taking turns behind the scenes. This is also why hardware suddenly matters again. For a while, many phones felt powerful enough for normal use. Better cameras, brighter screens, and longer battery life were obvious upgrades. But the processor was not always exciting to the average buyer. On-device AI changes that. More memory, faster neural processors, and better thermal design can decide which AI features a device can run. That does not mean everyone needs to buy a new device immediately. It means AI features will increasingly be tied to hardware limits. Some tasks will run on older devices. Some will need newer chips. Some will only work online. Some will only work in certain languages or regions. The experience may be uneven for a while. And this leads to one of the biggest consumer frustrations. The marketing may say AI is built in, but the fine print may say only some features are local, only some devices qualify, and some requests still go to the cloud. That is not necessarily deception. It is the reality of the technology. But users should know what they are actually getting. So, what will people notice first? On phones, AI will feel more woven into the operating system. You may see smarter notification summaries, better voice typing, live translation, photo search, call notes, screen understanding, and assistants that can use your personal context without needing every small task to leave the device. The phone may become better at helping in the moment, not just answering questions in an app, but understanding what you are doing across apps. On laptops, the shift may show up as local search and memory features. Your computer might help you find something you saw earlier, summarize a meeting, clean up audio and video, translate captions, or help with files without uploading everything by default. This is powerful, but also sensitive. A computer that remembers your activity can be useful. It can also become risky if the data is exposed, poorly controlled, or collected without clear consent. Local processing reduces some risks, but it does not remove the need for good security and user choice. On glasses, on-device AI may be even more important. Smart glasses cannot depend on a slow cloud round trip for every moment. If they are going to identify objects, translate a sign, respond to voice, or help with navigation, they need fast local processing. At the same time, glasses have tiny batteries and strict heat limits, so they may use very small models on the glasses, a stronger phone nearby, and the cloud only when needed. In cars, the same pattern appears. A car may use local AI for voice commands, driver assistance, cabin sensing, and basic navigation help, especially when the connection is weak. But cloud systems may still handle map updates, larger planning tasks, and services that need current information. Across all of these devices, the future looks less like one AI and more like a team of AIs. A tiny model on your earbuds, a bigger one on your phone, a stronger one on your laptop, a huge one in the cloud. The hard part is making them cooperate without confusing the user or leaking private information. There is another reason this shift matters. AI that lives on your device can become more ambient. A cloud chatbot usually waits for you to open an app and ask a question. On-device AI can work quietly in the background. It can notice a pattern, prepare a suggestion, sort information, or make an interface easier before you ask. That can be helpful. It can also feel creepy if it is not transparent. The difference between assistance and surveillance is often control. Can you turn it off? Can you see what it used? Can you delete the memory? Can you stop an app from accessing a category of data? Can you tell when a request leaves the device? These questions will become more important as AI moves closer to personal data. The most balanced way to understand this trend is to avoid two extremes. The first extreme is believing the cloud is dead. It is not. The biggest models still need data centers. If you want the most capable reasoning, the largest context windows, advanced generation, or the freshest online knowledge, cloud AI will remain important. The second extreme is believing local AI is just a gimmick. It is not. A smaller model in the right place can be more useful than a giant model far away, especially when speed, privacy, offline access, and cost matter. The real future is hybrid. Your device will try to answer what it can. The cloud will help when the job is too big. And more of the magic will come from deciding where each task should run. That is why AI is moving back onto your phone. Not because phones are suddenly more powerful than data centers. Not because giant models stopped mattering. But because the most personal AI has to live close to the person. It needs to see the screen when you need help. It needs to understand your voice without a pause. It needs to work in a subway tunnel. It needs to protect information that should not casually leave your device. And it needs to do small, useful things all day without turning every interaction into a server bill. So when you hear about an AI phone, an AI PC, or smart glasses with an assistant built in, ask one simple question. Which parts run here and which parts run somewhere else? That question tells you more than the branding. It tells you how fast the feature might feel, how private it might be, how much it depends on the internet, and how much the hardware really matters. The future of AI is still in the cloud, but increasingly it is also in your pocket, on your desk, on your face, and inside your car. And the most interesting part may not be the biggest model anymore. It may be the small one that is close enough to help before you even think to ask. If you have a question about on-device AI, privacy, AI phones, or what these new chips actually do, leave it in the comments. And if there is another future technology you want explained next, suggest it below.